Some of the most interesting pictures taken of space are those of nebulas. So what is a nebula? How does it form? What is it made from? And what creates the light and shade in the images of a nebula? Well, there are several well-known nebulas like the Pillars of Creation, which are part of a much larger Eagle Nebula. Then there's the Horsehead Nebula, or the Omega Nebula, which is sometimes also called the Horseshoe Nebula, since both terms refer to a similar shape. And then there's the Ball-like Crab Nebula. First thing to say is these nebulas are normally quite far away, so require a telescope or similar device to make out any of the details. And while early telescopes can make out some of the details, they can give a very basic idea of the shape, size, and scope of the nebula. Only with modern specialist telescopes, and especially those with dedicated filters, do the full extent of the size and content of the nebulas become apparent. This in turn does mean that some of the most spectacular pictures of nebulas aren't what might be described as actual true pictures of the nebula. Instead, a composite or an enhanced view of actually what's going on. Especially the case since not all the wavelengths shown in these images are of visible light. They are really representations of the full electromagnetic spectrum being released by the nebula. So like most of the universe, nebulas contain mainly hydrogen and helium. However, they may also contain small amounts of other elements, and in addition, some of these atoms may actually be ionized. The general description for a nebula is a cloud, which is a fairly good basic description, but a nebula is really less substantial even than a cloud. Most of space is a near-perfect vacuum with only very widely scattered elements of hydrogen and occasionally helium present. A nebula is basically a slightly less perfect vacuum, with a few more atoms present than is normal, what's known as interstellar medium, or the gaps between the stars. This marginally denser area space can then result in the gravity of the dust of a nebula pulling the atoms towards each other, resulting in an even denser cluster, eventually resulting in a star being formed. This star formation is why nebulas are sometimes called stellar nurseries, as the clouds are giving birth to stars. When these newly formed stars start to shine, they can potentially illuminate the nebula, just like a sun does from behind a rain cloud. And some parts of the cloud will glow differently to other parts. If this new star is hot enough and close enough, light from the star can ionize parts of the nebula, so as high-energy ultraviolet light strikes the atoms in the nebula, they absorb the energy, then later release this energy as light, which causes the nebula to glow quite brightly. However, if the illuminating star isn't quite as hot, then instead of ionizing the atoms, the energy from the star is simply reflected off the atoms. The resultant light, which is then seen in the nebula, isn't quite as bright. In addition, if there's more than one star illuminating a particular nebula, the stars will produce some areas of bright light which will dim away to virtually nothing before another star illuminates a different patch of the nebula. This can then result in some of the intricate patterns which we see on Earth, and in turn fascinate the people observing them. Now, the origins of nebulas can vary. Sometimes they're just a general area of the interstellar medium that then clusters together under gravity that hasn't yet been used up in star formation. Other nebulas can be formed from the matter scattered by a supernova. This supernova scattering will result in the nebula having a much wider range of elements present than normal, and the action of this supernova will ionize the atoms, meaning they don't require a current star to make them glow. Nebulae formed from a supernova will tend to be ball-shaped, lack some of the more intricate patterns of other nebulas. These kinds of nebula tend to expand over time, and then as the energy is released from them, the nebula will also fade over time. So they might start off small and bright and become large and dim. The remnants of the original supernova, however, may also become a pulsar. This pulsating energy released by the pulsar may in turn pass on that energy to the nebula, making it glow. In addition, these ball-shaped nebulas may pass through or interact with another nebula, may create some really intricate patterns.